Very light skin, porcelain to ivory tones. Very light skin, often associated with regions of Northern Europe and parts of Northeast Asia, represents an evolutionary adaptation to environments with low ultraviolet radiation. One of its hidden advantages lies in its remarkable efficiency at synthesizing vitamin D. In areas where sunlight is weak for much of the year, lighter pigmentation allows more UVB rays to penetrate the skin, triggering vitamin D production more effectively. This biochemical efficiency helped prevent rickets, immune dysfunction, and reproductive complications in ancestral populations living at high latitudes. Another subtle advantage involves circadian rhythm regulation. In lower light environments, heightened sensitivity to sunlight may have supported stronger seasonal signaling to the body's internal clock. This can influence serotonin levels, melatonin cycles, and overall mood regulation, potentially offering adaptive benefits in environments with long winters. Very light skin also makes certain physiological changes more visible. Flushing, pallor, or inflammation can be detected quickly, which in ancestral social groups may have improved communal awareness of illness or stress. Earlier detection of infection or environmental threat within a group increases collective survival odds. Additionally, lighter pigmentation requires less melanin production, meaning metabolic resources are allocated differently within the body. Melanin synthesis is biologically costly. In regions where intense UV protection was less necessary, reduced melanin production allowed energy to be directed toward growth, reproduction, and immune development. There are also thermoregulatory implications. In colder climates, where solar heat absorption is less critical than vitamin D acquisition, lighter pigmentation does not impede survival. Instead, cultural adaptations such as clothing worked alongside biology, allowing populations to thrive in environments that would otherwise limit human habitation. These advantages are not about superiority, but specialization. Very light skin reflects the human body's precision in responding to geographic and environmental pressure over thousands of years. Light skin, beige to fair with moderate pigmentation. Light skin with moderate pigmentation occupies a middle ground in UV adaptation. Found widely across Europe, Central Asia, and parts of the Americas, it balances vitamin D synthesis with moderate UV protection. This flexibility is one of its hidden strengths. With slightly higher melanin levels than very light skin, individuals in this range have increased protection against DNA damage, while still maintaining efficient vitamin D production. This balance is particularly beneficial in temperate climates where UV exposure varies significantly across seasons. Another advantage lies in adaptability. Populations with light but not extremely pale skin have historically migrated successfully across varied latitudes. The moderate melanin concentration allows resilience in both cooler northern climates and sunnier southern regions without dramatic physiological disadvantage. There is also a photoprotective nuance. While lighter skin burns more easily than darker tones, it also signals UV overexposure quickly through redness and inflammation. This visible feedback acts as an early warning system, encouraging behavioral adaptations such as seeking shade or covering skin before severe cellular damage accumulates. From an evolutionary standpoint, moderate pigmentation may represent transitional adaptation during human migration out of Africa into Eurasia. Genetic diversity within this range is vast, suggesting strong selection for flexibility rather than specialization. Light skin tones also demonstrate efficient folate preservation under moderate UV conditions. Folate is critical for DNA synthesis and fetal development. The balance of melanin helps prevent excessive degradation while still allowing sunlight-mediated processes essential for health. In essence, light skin represents adaptive equilibrium, capable of functioning across environmental gradients without extreme vulnerability to either UV deficiency or overload. Olive skin, golden, Mediterranean, and West Asian tones. Olive skin is characterized by higher eumelanin content combined with undertones that reflect carotene distribution and vascular structure. This pigmentation is common in Mediterranean regions, North Africa, the Middle East, and parts of South Asia. One hidden advantage of olive skin is its optimized UV filtration. It offers substantial protection against ultraviolet radiation while still permitting adequate vitamin D synthesis in sunny climates. This makes it particularly suited for regions with strong but not equatorial UV intensity. Olive pigmentation also shows resilience against photoaging. Increased melanin reduces collagen breakdown triggered by UV exposure, meaning structural skin integrity can remain stable longer under sun exposure. This is not merely cosmetic. Maintaining collagen density preserves barrier function and reduces infection risk. There is also an inflammatory modulation component. Higher melanin levels are associated with reduced UV-induced inflammation, which may lower long-term oxidative stress. Oxidative stress contributes to cellular aging and immune compromise, so mitigation provides subtle longevity advantages. Historically, olive-toned populations thrived in agricultural civilizations with high sun exposure. Pigmentation allowed extended outdoor labor without catastrophic folate depletion or severe photo damage. Folate preservation is particularly important for reproductive success, and olive skin strikes a protective yet flexible balance. Another lesser-known advantage is camouflage adaptation. In environments dominated by earth tones, rock, sand, and vegetation, olive pigmentation blends effectively, which may have provided ancestral survival benefits during hunting or conflict. Olive skin demonstrates how melanin levels evolved not simply as defense, but as calibrated filters responding to environmental light intensity, geography, and lifestyle patterns. Medium brown skin, warm brown to copper tones. Medium brown skin contains significantly higher eumelanin concentrations, providing strong natural protection against ultraviolet radiation. This pigmentation is widespread across South Asia, Southeast Asia, Latin America, and parts of Africa. A primary hidden advantage is robust DNA protection. Melanin acts as a natural sunscreen, absorbing and scattering UV radiation before it penetrates deeper skin layers. This reduces mutation rates in keratinocytes and lowers the risk of UV-induced cancers in high sun regions. Folate preservation is another critical factor. UV radiation can degrade folate circulating in blood vessels near the skin's surface. Higher melanin concentrations reduce this degradation, protecting reproductive viability and embryonic development. In equatorial or tropical climates, this protection is evolutionarily decisive. Medium brown skin also exhibits lower rates of photoaging. Structural proteins such as elastin and collagen degrade more slowly under UV stress, preserving barrier function and wound healing efficiency. Enhanced barrier integrity limits pathogen entry, which historically mattered in humid, microbe-rich environments. Thermoregulation may also play a role. While darker surfaces absorb more heat, the body compensates through sweat gland efficiency and vascular adjustments. Many populations with medium brown skin evolved in climates where heat dissipation mechanisms are highly refined. Another advantage is resilience to hyperpigmentation from minor injuries. While discoloration can occur, the underlying melanocyte activity often contributes to rapid protective responses against inflammation, reinforcing the skin's defensive architecture. Medium brown skin represents an advanced UV management system, designed to endure prolonged sun exposure without sacrificing reproductive or immune stability. Deep brown skin, rich brown to dark chocolate tones. Deep brown skin, common in sub-Saharan Africa, parts of South India, Melanesia, and among diasporic populations worldwide, contains very high concentrations of eumelanin. This pigmentation offers some of the strongest natural UV protection found in humanity. The most significant hidden advantage is exceptional defense against ultraviolet radiation. High melanin density absorbs a substantial percentage of UV rays, dramatically lowering the risk of DNA damage. In equatorial regions where UV intensity is year-round and extreme, this level of protection is critical. Folate preservation reaches peak efficiency in deep brown skin. Protecting folate ensures neural tube development in embryos and supports cellular replication. In ancestral equatorial environments, this advantage directly influenced population survival. Deep brown pigmentation also reduces the incidence of certain UV-related eye and skin conditions. By limiting UV penetration, systemic oxidative stress may be reduced, protecting not just skin but overall cellular health. Another advantage involves microbial resistance. Strong barrier integrity and melanin's potential antimicrobial properties may have contributed to survival in tropical climates rich in pathogens. While melanin is primarily protective against radiation, emerging research suggests it may also bind harmful compounds, adding another layer of defense. Deep brown skin also shows delayed visible aging due to slower photodegradation of dermal structures. Structural resilience supports long term tissue function, which historically improved caregiving capacity in multi generational communities. This pigmentation reflects humanity's origin near the equator. It represents an evolutionary masterpiece of protection, stability, and environmental alignment. Very deep ebony skin, darkest melanin rich tones. Very deep ebony skin contains the highest concentrations of eumelanin and often larger, more densely packed melanosomes. Found predominantly in equatorial African populations and certain Melanesian groups. This pigmentation evolved under the most intense solar radiation conditions on Earth. Its primary hidden advantage is maximum ultraviolet filtration. In equatorial zones where UV exposure is extreme and consistent, this level of melanin protects against cellular mutation, folate depletion, and severe photodamage more effectively than any other pigmentation range. The density and distribution of melanosomes in very deep ebony skin also enhance durability. These melanosomes are often larger and more individually dispersed, providing consistent protection across epidermal layers. Another advantage lies in resilience against certain environmental toxins. Melanin can bind heavy metals and reactive oxygen species, potentially reducing oxidative burden in high exposure environments. Very deep ebony skin also demonstrates extraordinary structural strength in its barrier function. This may have offered protection against dehydration in hot climates and resistance against microbial invasion in humid ecosystems. From an evolutionary perspective, this pigmentation represents the original human template. Modern humans evolved in Africa under intense UV radiation, and very deep ebony skin safeguarded early populations during humanity's formative millennia. It is not an exaggeration to say that without this level of pigmentation, early Homo sapiens might not have survived long enough to migrate, diversify, and populate the globe across all skin colors. Each skin color reflects adaptation, not hierarchy. Pigmentation is the result of precise genetic tuning influenced by geography, sunlight intensity, altitude, diet, and migration patterns. Melanin acts as both shield and regulator, balancing protection with essential biochemical processes like vitamin D synthesis. The hidden advantages of skin color are deeply contextual. What is protective in one region may be limited in another. Human diversity is a map of ancestral sunlight exposure written onto the body. Every tone, porcelain, beige, olive, brown, deep chocolate, ebony, tells a story of survival. Skin color does not define ability, intelligence, or worth. It defines adaptation. It is biology responding intelligently to the environment over thousands of years. Keep learning, keep embracing what makes you unique. Subscribe and explore the science that makes you extraordinary.